Alright, so now we're going to talk about our rational zeros theorem. Okay, and you can read through this definition for a minute, but basically what we've done in the past is they've given us some function and they've asked us to factor it, yet they've always given us something to start with. Now once we found this first number, then it was a matter of doing either bottoms up or a quadratic formula to get the other two, so it hasn't been that challenging. But in the particular case in number 5, when it says, if they told me to factor this polynomial, and they didn't give me anything to test, to try to see if it was a zero of it, I'm essentially just shooting in the dark with taking synthetic division and trying all the random numbers till I find something that gave me a remainder of 0. And then I would have to continue that process over and over and over again. Well, what the rational zero theorem does for us is, let's just say, let's just say that this blue area represents all the numbers that are out there and could possibly give us a remainder of 0 when we divided it out of this polynomial. I could literally just start with 1, try synthetic division on it, see if I got a remainder of 0. Then I could try -1, see if I got a remainder of 0. Keep going. 2, -2, 3, -3, 4, -4, and on and on and on until I eventually found all the factors of this polynomial. Well, you can see that that would take forever. What the rational zero theorem does is it gives us a method that lets us pick in here so that we know all these numbers in here could possibly end up being a 0. A 0 meaning something when we did synthetic division would give us a remainder of 0 of this function. So instead of being way out here in this big infinite amount of guessing and a lot of work, we're able to cut that down to a smaller size. Now all of the solutions, all of the roots and the zeros are within this little region, but it doesn't mean that every single one of these are. So this one might be a 0, this one might be a 0, this one may be a 0, and let's just say this one. So there is still a little bit of guess and check that we're going to have to do to find our particular zeros, but it's not nearly as big as all the guessing that we've had to do out here. So what we're doing with this rational theorem is we're listing all the possible rational zeros. So we're getting in this red region by this list. Okay, now let's see if we can kind of clear that up algebraically. Plus or minus, it says plus or minus p over q. P is the factors of the constant term. So we have plus or minus p plus or minus q, where p is going to be the factors of the constant term. Factors of constant. And q is going to be factors of leading coefficient. COE. Okay. So in our particular case, our constant term, this is our constant term, so this is going to be our P. All the ways to get 3 are 1 times 3. So I'm going to put plus or minus 1, plus or minus 3. That's the only way to get 3. And then the next thing, our Q comes from this leading coefficient. All the factors of 2 are just 1 times 2. So plus or minus 1, plus or minus 2. Okay, now we want to simplify all the options out of this. So first of all, I'm just going to say 1 divided by 1 is just 1. So of course I'm just going to keep plus or minus in front of it. And then I'm going to say 3 divided by 1 is just 3 and keep the plus or minus in front of it. Then we come back here and we're going to divide everything by 2 this time. 1 divided by 2 is just going to be plus or minus 1 half, plus or minus 1 half, 1 over 2. And then I'm going to do this one, which is going to be plus or minus 3 halves. These are all the possible roots. This basically gets us in our red region. in that picture that I was talking about before. So I would still have to do synthetic division and test all of these to find out which ones are going to be zeros for this polynomial. Alright, let's do that one more time. Let's list all the possible zeros for this polynomial function and then express it as linear factors. Okay, so this time we're going to take it a step further. First of all, we're going to do our plus or minus p over our plus or minus q to find out what they are. The p is going to be of 8, and we don't need to worry about it being negative 8 because we're going to have plus or minus everything. So all the ways to get 8 is 1 times 8 and 2 times 4. So I would say plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. That's all the factors for our constant term. And then our leading coefficient is a 1, so the only way to get that is plus or minus 1. Now when we simplify this, we're basically going to divide this one by 1, 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 but in the end we know anytime you divide by 1 you get itself. So all of our possible zeros are going to be these. That means those are all the things in the red regions. Now out of all of these we need to figure out which ones truly are factors of this. So I'm going to take my original polynomial and I'm going to set up synthetic division. So let me draw me a line because this is the second part. So right, I'm back up here. 1x cubed, 5x squared, 2x minus 8. Synthetic division. 1, 5, 2, negative 8. Now I'm just going to start with positive 1. There's no rhyme or reason to how you start or progress through these. You just start with 1 and just plug it in and try it. So I'm going to start with positive 1. And I'm going to do synthetic division to it. 1 times 1 is 1. Add down, start over. Then I'm going to say 1 times 6 is 6. Add down. 1 times 8 is 8. And I was lucky because I know since I got a 0 that 1 is a factor. Okay? And all that means is now I have x minus 1. If the original polynomial is an x to the third, then this is an x squared. So what's left is x squared plus 6x plus 8. So I got lucky and I found one. Well, since I found one, I don't have to keep on going through these doing synthetic division because I'm now at a quadratic in x squared, so I can try bottoms up. Once you get to an x squared, we usually try to use bottoms up to save us some time. Okay, what multiplies to give us an 8? 1 times 8 is 8. Adds to give us a 6. So 2 times 4. And then 2 plus 4 is 6, so this works. The coefficient is a 1x. So then right from the bottom up, so this becomes x minus 2, x plus 2, excuse me, x plus 4, and we drop the first. These are all the possible factors. Now let's look at it. Is the 2 and the 4 included in the possible? Yes. So it verifies, but the method to the madness is that you are going to use our rational theorem to determine our guessing pool. So this gives us our guess. We just start with 1. If it works and we're down to an x squared, we can use bottoms up. If it didn't work, if this would have been any number, I would have just went to -1 and tried it. Then went to 2 and tried it until I figured out what all of these were. What all of these factors were going to be.